Good morning to you all. Myself C. Ganesh and CSA. Today's topic is polymer prism. Introduction to polymer prism. Polymer prism is a core concept in object-oriented programming that allows objects of different classes to be treated as instructions of a common superclasses. In It enables a single interface to control access to a verify of understanding data types or classes. This concept promotes flexibility and responsibility in code design. Definition of polymorphism. Polymorphism means many shapes in Greek, highlighting the ability of different objects to respond to the same method called in different ways. It always method to behave differently based on the object that inquires them. Polymorphism is achieved the thought method overriding and method overloading in programming languages. Types of polymorphism. Compare time polymorphism, also known as static polymorphism, is achieved thought method overloading and operator overloading. Runtime polymorphism or dynamic polymorphism is achieved thought method overloading during program execution. Both types the flexibility and responsibility of software systems. Methods overloading. Method overloading always multiple methods with the same name but different parameters with the same classes. It provides compile time polymorphism by selecting the appropriate method based on agreements. This technique improves code readability and usability. Method overriding. Method overriding occurs when a subclasses provides a specific implementation of a method earlier definition in its superclasses. It is a key feature of runtime polymorphism that enables dynamic method syntax. Overriding helps in achievement polymorphic behavior and customizing engineering methods. Benefits of polymorphism. Polymorphism specifics code maintenance by allowing new behaviors to be added with manual changes. It increments code responsibility by enabling the same interfaces to work with different data types. Polymorphism supports the open closed principle, making systems easier to end and modify. Polymorphism in practice example. Consider a superclasses shape with a method. Draw and subclasses circle and square. When calling draw on a shape, reference the correct subclasses method invoked at runtime. This demonstrates how polymorphism enables flexible and scalable code design. Changes of polymorphism. Overusing polymorphism one can lead to complex code that is difficult to understanding and debug. It may introduce performance overhead due to dynamic method dispatch at runtime. Proper design and understanding are essential to effectively leverage polymorphism without drawbacks. Polymorphism in programming language. Many object-oriented languages like Java, C++, and Python support polymorphism explicitly. Java uses method overriding and interface to implement polymorphism. C++ implies virtual functions and functions overloading to achieve polymorphic behavior. Conclusion. Polymorphism is a fundamental principle that changes the flexibility scalability and maintainability of software. Understanding both the compiled runtime and runtime polymorphism is essential for effectively object-oriented design. From application of polymorphism leads to more updates and available software systems. Thank you.